We've talked a little bit about matching the platform and the sensor to match that mission objective. But let's take a little bit closer look at some of the sensors that are out there and where you might want to go with the software to process that. And we're going to get more into the software later on in these modules, and we'll actually do a project using Pix4D. But let's get a little bit of common ground here as far as the nomenclature and what we're really talking about. So there's several data products that are out there, and these are just some of the data products that are available, but they're basically grouped into what I think of as two different areas. You have the first area, which is kind of the novice area that anybody can go out and do as a recreational pilot, and that's just the images. You might stitch some images together, you might get a 360-degree view, and you might have some neat video that you can put together. And in some cases that might be all that you need. For example, for a realtor or something like that, or doing a wedding shoot or an event, that might be all that you are interested in doing. Taking it to the next level though, we get into the mosaics, we get into terrain models, we get into 3D models, vegetation indices, and a whole slew of other products that we can create with the imaged data that we are collecting. So if you take a look at the sensors that are out there, they're obviously the ones we know about, which is your general RGB type of sensors that we have. But there is a little bit of confusion on the resolution, and this is an important piece because a lot of the manufacturers out there will try to tout their great capabilities of their platform, and they're going to spin it in a way that makes it the absolute best that it can be. But taking a little bit closer look at that and understanding what the numbers are is a very important piece of this. So a lot of times you'll see either image resolution, a 16 megapixel image, for example, or video resolution, a 1080p or a 4K video. As you can see just to the right here on the quality scale that we have, the ability of the camera is based on these, and you're generally going to run cameras on a platform in this area up here. 1080p is considered the lower end of your HD, and then up to your 4K. But realize that your 4K video is not that much higher than really the 1080p. It's about double the amount of pixels in the vertical, but it's not a huge difference there. But it does create a lot more data storage space that you'll need. I'm not saying you don't want to shoot 4K video, but there's definitely some considerations for it. If you take a look over here, this is the Hero 5 that does shoot the 4K video and has some great capabilities, considering the fact that it has automatic Geo Tagging, and it also has voice activation, which is very nice for some of the applications. You have your regular capability with a zoom lens here for the Inspire platform, DJI Inspire platforms. This is a Zenmuse XT thermal imaging camera. And then you have the MicaSync Red Edge and the Parrot Sequoia sensors down here. Just to give you an idea, $400 to $500, about $600 to $700. This one, depending on the resolution, there's two resolution models of it. One's 320 and one's 360, and one's 520. The 360 is about $5,000, and it's about $10,000 for the 520. This sensor down here is approximately $5,000, and this one down here is about $3,000, just to give you an idea. So the frame rate is also very important on these cameras, and a lot of times with drones, and depending on what you're doing, I find it better to shoot at a little bit lower quality but a higher frame rate. 30 frames per second is the standard that's out there, that you're not going to be able to pick up the frames flipping by with your eyes. But you want to keep in mind that when you're shooting a lot of video, slowing it down and doing slow motion effects, then speeding it up, is something that's very attractive in videos. So typically I tend to shoot, most of my just default going out the door shooting is done with a 60 frame per second video, and I generally aim for somewhere in this area of the HD spectrum versus going all the way up, because that's going to reduce my data storage a little bit, and really on a typical screen you're not going to be able to tell that much difference. You can also go up to 120 frames per second on a lot of these, and that again is going to allow you to slow that down now basically 4 times into a slow motion type of version and get some real good quality slow motion video in there. The image resolution, this one you have to be a little bit careful with as well, because some of the cameras out there, you might have heard of a fisheye camera, and they're very wide field of view. They might be as much as plus or minus 80 to 85 degrees a field of view. So you're getting almost 180 degree field of view with that type of a lens. But realize if you want to zoom in on something, there's a huge difference, and I'm talking a digital zoom, not optical zoom. If you want to zoom in on something, there is a huge difference between a camera that is just focused in say a plus or minus 30 degree field of view compared to one that is a plus or minus 80. So you've got to be careful on the way that they say that. And then zoom is another very important one, and if you're into doing any inspections or anything like that, you're going to want to have some sort of camera that has a zoom capability, if not just a lens that is more of a telephoto lens, because your standard UAS, whether it's an Inspire or a Phantom 4 or a unique platform, they're going to come with a very wide field of view camera, and in order to be able to get very detailed resolution of a roof or something like that, you're going to have to be inside of about 10 feet, which can get very, very squirrely. And if you want some very detailed imagery, probably inside 5 feet. So a zoom is very important if you're going to be doing inspection with it. Another important piece to look at is geotagging. Geotagging is something that you don't necessarily have to have. In other words, you don't have to have the picture with the embedded metadata that has the lat and longs, but in most cases it's very nice to have that. This camera up here, again, the GoPro standalone, does that, and it geotags it itself. Be careful with, again, your drone purchase to make sure that you have an aircraft that is going to tag that directly to the image. Otherwise, you're going to have to get into log files and photo files, match them up, and it can get fairly tedious making that happen. File type is another important one. Everybody knows about JPEGs, but a lot of times shooting RAW is going to give you a lot more information inside the pixels itself. So if you want to get very much into the Photoshop side of this, shooting in RAW is typically the way that you'd want to do that. Infrared, we've talked about this a little bit, but there is a near, realize they're not all the same. There's near infrared, there are short wave, there's medium wave, and long wave. Most of the cameras you're seeing out there are going to be using that area of the spectrum from about 7 to about 12 or 13 microns is where they're going to live, and they're out there in that medium to long area, which doesn't require as much cooling. So that's where those are going to be at. The reason I mention that is because the different spectrum areas may or may not give you the information that you want in those areas. So again, just do a little homework on that. And then there's the multi-spectrals, which are going to multi-spectral and hyperspectral, which are going to give you small resolution, high resolution bands in certain areas. These two over here are specifically made for agriculture, and those bands are specifically designed to be able to see different wavelengths that the plants either reflect or absorb. So if you look at the different products that are out there for these two major different areas, there are several of them out there, and again, this is just a list of a few of them. But one of the very easy ways to start is with Gopro Studio. It's free, it's out there, and it's a great way to get started. DJI Go has quite a bit on there. The Windows Movie Maker as well. With that, there's a Filmora, there's Color, and there's the Adobe Premiere Pro. There's literally hundreds of different ones out there, and it just depends on the level that you want to get into the processing for these. Hanger is another one that you can use for 360. That is a very nice stitching and processing software. To create the mosaics and the terrain and 3D models, you're going to require a little bit higher end photogrammetry type of software. Again, the list that we saw earlier there's a lot of them out there. But you have it down to a few that are your typical industry type of standards. Pix4D tends to be that industry standard. Everybody else kind of compares himself to that. Drone Deploy is very similar to Pix4D. It doesn't allow as much capability of the actual software and analyzing what is really going on as Pix4D, but it's still very, very good software. MicaSense Atlas and Agrasoft are other ones that can be used in that area as well. When we start taking a look at some of the stitch mosaics, what that allows you to do is to take photographs and be able to stitch them together to have large area mosaics. And this is a mosaic that was actually taken down at about 150 feet. But you can see from this view, it looks like when it's put together that it's taken from up there at probably about 500 to 1,000 feet is the actual view you're getting. The beauty of this, though, is that it gives you very high resolution pictures of the whole area. So if we zoom in on this picture right here, we can see that it can go all the way down here and see some of the tornado damage here in Oklahoma, and it really is able to give a very high resolution mosaic versus just a single snapshot. So it gives a lot more information in there and why you generally want to use mosaics. 3D models are going to be that next step up, and these are very good for planning and cataloging different things, because the accuracy of the measurements and the volumetrics and the areas in this can be extremely high if you use ground reference points for your GPS or some other methods that are out there, but you can get accuracy generally down to centimeter accuracy in measurements, and even sub-centimeter accuracy if you have some good RTK GPS data. So they can be extremely valuable for measuring distances and things like that. And lastly, we have just multi-spectral type of things we can take a look at. The indices that can be created with the different multi-spectral sensors is still being studied. We don't know exactly how this can be used for a lot of the different crops out there, but there's a lot of research going on with this right now. That's an example here with the Parrot Sequoia sensor. Like I said, it's about 3,000 for that, and then the MicaSense. And MicaSense just came out with another one, by the way, that's about half this size. It's literally a GoPro type of size. I think they're calling it their Red Edge M is what they're using. And this is an example of the Atlas software that goes along with that. So hopefully that gives you a little bit better idea about some of the capabilities the software has out there. You really need to match how much you want to get into it and what the requirement is with the program, because sometimes you get into these programs and they are so in depth that they make it extremely difficult to get the basics done. Other programs are just too simplistic, and you'll have to find the balance and what you want to get to for the actual processing.